All right, our problem here today is pretty long. Not too complicated, but let's get through it. So, create an empty list, for loop to give it a bunch of random numbers, print those numbers, print the sum, sort the list, print the sorted values all on the same line. Slice them out, print the slice, print the finish, slice the finish, print the finish, do some even odd, make this even odd function, and then print the returned. So that's that part, the even odd part, and the example. Use a for loop to test for and add up the odd and even values. Print the total of each even and odd elements found. Print the sixth element of the list, return even and odd sums, which is a multi-value single return statement. Okay, let's see if we can do this. I'm going to move these maybe down here. We'll bring them back up. Probably won't need this as much, but all right, so I have a command line to just run the program, and then I have the programs. I think it'll be easier to run it like that. Running. Gonna have some function. I'll have the even odd function. My list. So it's going to be our list of numbers. We'll pass for now. That just means don't do anything, but don't yell at me. If name equals main, print, okay. And then we'll do stuff in here, I guess. Sure. I guess we'll get rid of this. All right, what do we want to do? The even odd stuff is going to come later, so we'll do our fun stuff in the if name equals main. What do we want? Empty list name nums. Okay. Nums, empty list. We need 15 random integers, 41 to 30, 41 to 83. 15 of them. We need random, I think it said. Let's do it. For loop, we can do that. For I, for anything, we can even say underscore because we're not going to use it in range 15. 15 times we want to do this. Nums.append and random.randint 41 through 83. I think I checked and the randint is inclusive, so it meets our needs. So let's just print nums, see what it's looking like. Okay, that looks good. Is that what we want? Final output? We'll find out. We do, but we don't want that little thing on the front. So we're going to need to print it without. And that's going to be the handy, I don't even, what is it called? Unpacking operator. That is going to fix that. That's going to unpack all of the values in an iterable so that it basically turns print 1, 2, 3, 4, 5 into print 1, 2, 3, 4, 5, which will be interpreted exactly as we want it, I think. Great. We can get rid of the OK, I think. What's next? Sum of the random numbers. Easy enough, I think. Print sum of the random numbers is some nums. That should do it. Let's see. Flying along here. No. Something. I leave out a parenthesis. Oh no. Bad news. Let's try that again. Sum is some nums. Maybe the parenthesis will help. Cool. All right. Next step. What is this? This is the first one, two, three, four, five, six, seven, eight. First eight and last four of the sorted. So we're going to be dealing with sorted. Oh, we didn't even do that yet. We need to do the sorted list and then splice out 8 and 4 from the front and back. All right. Sorted is a method, so it's very easy. Sorted will just do the work. However, if we just print sorted nums, that will not be quite what we want because it's going to print out those brackets. But we can just do the same thing that we did with the star on the front, and that will be what we want. I don't remember what do they want us to call it? First eight or something? Start and finish is going to be the first four. Start equals. So we want it based on sorted nums and the first eight. So to index, if you want eight, it would be 0 through 8. If you're starting at 0, you don't have to put the 0. And this is 8, even though it's 0 through 8, it doesn't include 8. So it's 0, 1, 2, 3, 4, 5, 6, and 7, which adds up to 8 because you start at 0, even though it doesn't include the 8th index. Okay, that's start, finish equals sorted nums. When you're going from the back, you can use negative numbers. And if you want to go to the end, you would just leave off the last number. So if you wanted to go to the second to last, something like that, you could do that. But we want to go to the end, so we'll do that. And how do we want to display them? Oh, they don't care about the brackets, so we'll just print them. Print, start, print, finish, and let's check our progress. Looking good, I think, so far. All right. And now we pass to the even odd function. So we're going to pass this whole list to, I think we're going to do something with the return value. So I'll call it value equals even odd. And we're going to pass the list, the sorted list, I think they said, though I don't believe that will change the result, but do what they tell us to do. So we're passing the sorted list to even odd. And here we can just print my list and see that we've got it. We'll even put starting even odd function. Okay, so it passes the whole list. So we have this thing at this point in the function, we're calling it my list, but we're passing this into it. But from here, we're just going to call it my list and deal with it like that. So what do we want to do with it? We want to get evens and odds out of it. So there's a couple ways to do it, probably more than a couple. The Probably the starter way is to have evens and then go through a for loop. We'll do this in both ways just so you can see it can be done in different ways. We'll do evens in the sort of beginner way and then odds in a list comprehension way. So for number in my list, we can call that number anything we want, but since it's a number, we'll call it number. You could call it I, X, whatever you want, but we just have to refer to it right here. So what is an even number? An even number mathematically is can be determined by a thing called a modulus. A modulus is an operator, and that is the percent sign. What a modulus means is that when you're dividing, you have 10, what do we want to do? 9 divided by 4, right? 9 divided by 4 equals 2 and something, right? A whole number 2 and then a little bit more. Now, modulus is the remainder. So 9 divided by 4 is 2, and that takes care of 8, right? Because that is 2 times 4 equals 8. So the remainder is 1. 8 plus 1 equals 9. So I don't think I'm doing a great job at explaining modulus, but we'll do a couple more and maybe that'll be better. Um, so the modulus is the percent sign. So if you were to say 9% 4, that would equal 1 because it's the remainder. So if you have, what's 3 divided by 3? That equals 1. And what's the remainder? The remainder in that is 0. So 3% 3 equals 0. Let's go to 6. 6 divided by 3 equals 2. And what's the remainder? Is 0. So 6% 3 equals 0. What about 8? 8 divided by 3 equals 2. And a remainder? It is 2 gets us to 6 plus 2. So it's 2, which means that 8 modulus, or 8% 3 equals 2. So that's what this percent sign means. It's modulus. So the trick to an even number is an even number can be defined as a modulus of 0 because, well, excuse me, an even number modulus 2 equals 0. Think about it. If you have 8 divided by 2, there's no remainder, right? That means that 8 mod 2, 8 modulus 2 equals 0. 15 divided by 2, is there a remainder? Yes, the remainder is 1. It's 7 with a remainder of 1. So 15 is not an even number because 15 mod 2 does not equal 0. So this is what we're going to use to determine the logic to evenness. I hope that makes sense. Let's see it in action. If number modulus 2 equals 0, so this means mathematically if the number is even, evens dot append number, right? So we're only going to append it if evens, if it is even if it matches the condition that it's even. And then let's just check it and see, did this work? So hopefully we only have even numbers. 48, 62, 68. So we're good. So that's the longer way. The other way to do it is we'll do it for odds equals, and we're going to do a list comprehension, which we've talked about in another video. But it's just a way, if you have a situation where you have an empty list that you're starting with, and then a for loop, and then you're appending to it, likely you can rework that into a list comprehension. And a list comprehension is a list with a bunch of words inside of it. And the structure will be like this. Number, for number in my list. So this would be a list comprehension that says, this is the variable number. I'm sorry, let's call it number the same. Number for number in my list. So this means this is, as it stands, this would just be the exact same list. The odds would be the same because we're going to go through every number in my list and we're going to say that odds equals the list, every number in the number in my list. But we're going to add a condition. If number mod 1, mod 2 equals 1, print odds. Let's see if this worked. Hopefully it did. So 41, 45, 49, odd numbers. So those are the options. We could have done, I'd probably recommend doing it the same. If you're going to do it the second way, do it like this, where you do number for number in my list, if number mod 2 equals 0. Or if you're going to do it the other way, do odds equals this. And since there's only two conditions, the number is either going to be even or odd. You could just say else and then odds dot append number. So these are the complete way. This is the sort of beginner way to do it, and this is maybe the more advanced way to do it. Whatever suits your fancy, they both get the job done. Okay, so we have evens and we have odds. What do we want to do now? Use a for loop to test for and add up the odd and even values from the list nums. When finished, you then print the total of each even and odd element found. Okay, so I think that's just, oh, the total. Print the total of each. I read this to say that, oh, the total. So that is the count, right? It's not the sum. So the number of occurrences. I think there's a count. So print there are, oh wait, len. Len will do it because it's the length of the number of items. There are len evens, and len odds. I think that'll do it. Len odds. 6 evens and 9 odds. That looks to match. Okay. Print the 6th element in the list. Use a for loop to test for and add up the odd and even values from the list nums. Okay, print the 6th. Okay, we can do that. The 6th item, the 6th element in the sorted list is going to be the 6th element in the sorted list is Oh, well, we're calling it my list. And the sixth element would be the fifth index because indexing starts at 0. So that should do it. Let's check that one out. 56. Is this correct? 1, 2, 3, 4, 5, 6. 56. Okay. The sum of the evens is blank and the sum of the odds is blank. Okay, so this part is just returned. We don't print this in the even odd part. We print it in the main part. So um, we just want to return the values. So we can return two different values. We just return 3 and 4, 4 and 5. But how do we get them? Just return some, what is it, odds first or evens? Even and odd. Some evens, some odds. So this will return two values, sum of evens and the sum of odds. And those values will be assigned to the value that we assigned here. So we can then print that value, and it's going to be in a tuple, but we can mess with it down here. Hopefully, let's see what it looks like. So see, these are the sums, and this is going to be the even sum, and this is the odd sum. And now we just have to format it here. So the sum of the evens is that, and the sum of the odds is that. The sum of the evens is, and that is the first value, so the 0th index. Odds is, and that is the second value or the first index. So that should format it in the way that we want. Yeah, so that should do it. That's a pretty small number. The evens, there's only 5 of them. The odds, there's a bunch. And then the last thing is just to print a statement. I'll leave the printing statement to you. Hopefully you can do this. Um, a side note, if you wanted to, I like it better to assign the value. And so if you have two values coming back, to, you can assign them at the same time to different variables. So sum of evens, comma, sum of odds. Since we are returning a tuple that has two values, the first value will be assigned to sum of evens and the second to sum of odds. Certainly we don't have to since we did it this way, but it's prettier and more readable. So let's just verify this doesn't break everything. Yeah, there you go. So you can do it that way. That, I think, completes the problem. Take a quick look, see if there's anything. Yeah, we executed the even odd with sorted nums as its sole argument. Print the return sum values from even odd function. Yeah. All right, we did it. Let me know if you have any other questions or whatever. Have a good one.